In question 17, it says the annual precipitation amounts in a certain mountain range are normally distributed with a mean of 109 inches and a standard deviation of 10 inches. So I'll write that down. Mean is 109. Standard deviation is 10. We want to calculate the probability that the mean annual precipitation during 25 randomly picked years will be less than 111.8 inches. So I can write that as the probability that X bar, the mean for that sample, is less than 111.8. And we know that the sample size is 25, so that's N. So when I'm calculating a probability for a normal distribution, I use the normal CDF function. I put in my lower and upper bounds, and because we're seeing that the mean has to be less than 111.8, that means there is no lower bound, and I use negative 1e99 in place of negative infinity, because we have to have a number there. And then our upper bound is the 111.8. So now I'm ready to put in the mean and standard deviation, but it's not the mu and sigma that we were given for the distribution of the individual values. We need to find mu sub x bar, which is actually still the same anyway, so that's fine, and sigma sub x bar, which is going to be different. So we take the original sigma and divide by the square root of the sample size. Now in this case, that gives me 10 divided by the square root of 25. And since the square root of 25 is 5, I can simplify this to 2. So now I put in a mean of 109 and a standard deviation of 2, and when I calculate this, I get 0.9192. And that's my final answer for question 17. If this had not been a perfect square for the 25, then I would have just put it into the calculator as 10 divided by square root of 25 for sigma. Okay. All right, now let's take a look at question 18. So, the weights of the fish in a certain lake are normally distributed with a mean of 20 pounds. So again, I put my mean and a standard deviation of 9. So sigma is 9. If 9 fish are randomly selected, so we're going to have a sample size of 9. What is the probability that the mean weight will be between 17.6 and 23.6 pounds? So it was asking about the probability of the mean. And again, this means that when I look at my mean and standard deviation for this problem, I'm going to have to look at mu sub x bar, which stays the same, and sigma sub x bar, which is going to be the original sigma, 9, divided by the square root of the sample size, which is also 9. And that gives me 9 over 3, which is 3. So again, I'll use my normal CDF function. Lower limit is 17.6. Upper limit is 23.6. The mean is 20. The standard deviation is 3. And when we calculate, we get 0.67 3, 1. And that's how you do that problem.